Hello and welcome back. Okay, so I've got here the 16-bit address register that I built in the second video. Now we're not actually going to be working on this, but I was working through some of my old breadboards and I thought it was an interesting talking point. When I first came to start this video series, after the clock circuit, I had kind of one of two ways I could go. One was to build the count registers, and the other was to build the general purpose registers. So obviously I went down this road. The counter chips on here make it a little bit more interesting, but it's pretty much time now to look at the general purpose registers, because very soon we're going to have some computation and we need somewhere to do the work. New breadboard time. Okay, so I'm going to sort out some power for this. Okay, so we've got some power and time to think about how the registers are going to work. We've done quite a lot of work on other circuits and it's not actually very much that's new for this one. So the first thing I'm going to do is start off with one of these LS574 D-type latch chips. Now we first looked at these in the fourth video. They've got 8 input pins down on the lower side and 8 output pins on the upper side. These are tri-state outputs, so we're going to do the same as before. We're going to leave them outputting when we use them to store data for the register, same as we did in the pipeline. The feature of this pretty much does what we need. Of course, if we just needed a single device that was going to sit on the bus, store data and then output data to the same bus on demand, actually this chip is all we would need. At some point in the future I might actually experiment with a much simpler processor design like that, but for now let's stick with what we've got. So let's get some LEDs in there. And what I'm going to do here is I'm going to build 2 of them simultaneously. The main reason why we need GPRs at this point is we need to handle some sequencing from the pipeline to generate some data, and then we're going to consume it in the ALU when we get to that. Okay, so let's have a quick look and see if we've wired these LEDs the right way. That's good. Okay, so let's have a quick look back at this. So output enable is pin 1 and that is an active low connection. So let's bring both our pin 1s low. And then pin 11, this one up here, is our copy line. So that will load data from the bus. That is an active high line. Okay, so let's bring them low so they're not loading. Okay, I'm actually going to put those wires to one side for now, but we know where they belong. Okay, so we need the output lines in here which are going to represent our current stored value onto the LEDs. Okay, those lights are quite annoying when flashing, so let's tie the copy line low. Okay, so that's good. Okay, and here's where the wiring starts to get a little bit more complicated. We've got the input lines from the bus will be here. The register or the D-type latch will store those 8 bits that it reads from the bus and at present permanently output them into the LEDs, but we also need to take the outputs and do something with them. So we need to be able to conditionally assert them back to the bus. Now, once again, the chip that we're going to use to do this is one we've already dealt with before. Now, this is one of these 74LS541s. Now, we dealt with those in video 3. Now, before we noticed the issue where we wanted to hold on to a value while we were incrementing it in the count registers, we were going to be using one of these to assert the value from the count registers to the bus, and we've got no way of changing the contents of this register, so we may as well use one of these to do the job here. Now let's have a quick look at the pinout. So we've got our 8 inputs and 8 outputs. These are tri-state, which gives us that good bus driving capability. So when the chip is not enabled, they are, for all intents and purposes, not connected at all to the bus. So that's good. But here we are. The inputs are on the bottom and the outputs are on the top. So that's a little bit of a pain for us because our current data is at the top. So what I'm actually going to do is I'm going to turn this chip around and put it in upside down. Now I never like doing this because that does mean that we always have to remember which way round it is. So I'm going to put power in straight away. Okay, so these chips have 2 enable lines, one up here on pin 1 and the other one over here on pin 19. So we only need one of these. Now these are active low and they are ANDed together. So whichever one we're not going to use, let's go with this one. We'll take it low and then we can activate the chip. Okay, so now we need to take these 8 lines across to here in order to give the data to the bus driver. And this is obviously where the wiring gets a little bit difficult. This is where the wiring gets very, very difficult because I discover that I've got 16 wires I've cut last night that are all the wrong length. Okay, so I've retrimmed all 16 of these. So there's a tiny little kink in them all now, so it's going to make this bit even more difficult, but let's do it. Okay, before we go on, I feel like I need to test what I've done here. Now this was the little bus tester that I built in the 3rd video, or presented in the 3rd video. Okay, so if we bring that line high, it's not outputting. If we bring it low, it is. That's good. And all the wires appear to be hooked up. That one also works. That too is good. Okay, but we don't want to be moving these cables around. whenever we want to output to the bus. So what we need to do is connect all of these together because they're all supposed to be on the bus. Okay, so that's the bus outputs connected back to the bus inputs. So now we need to connect up the 8 bus lines here with the 8 bus lines here. Could do that fairly simply with a DuPont cable, but I think it might be a little bit neater to do something else. Okay, so I believe this is all connected up, so these 8 lines here are effectively the main 8-bit bus. Now I've left some space over here because there is some more work to be done when we start looking at inputs to the ALU. I did allude to this when we looked at part 13, but yeah, for now these registers are pretty good. I've built out 2 of these. I'm envisaging 4 of these general purpose registers at the moment in the final CPU, but the architecture I'm using here, using the demultiplexer chips to select devices on the bus, means that we could extend this out quite easily, but I've got to draw a line somewhere on the complexity of this processor design. If we bring the little bus test module back in and plug it into the bus. Okay, so let's think about what we've got here. I've got, on each of these registers, I've got these white cables which instruct the register to load from the bus, and I've got the yellow cables that are in the line drivers which tell the register to assert to the bus if I bring it low. And this matches the yellow wire over here, which is our temporary little output from these dip switches. Okay, so in theory the output from these switches, if I set this line driver low, will be displayed on these LEDs which are showing us what's on the bus. Let's put a different distinction on value on there. This switch is a little bit dodgy. Okay, so now this value is being asserted onto the bus, so we should be able to load that into one of these registers here. There it is, that works. So now we could take that off the bus and it's still there, and we could change this value. Dip switches seem like such a good idea before you discover that they don't stay in the breadboard very well. Okay, so set that one to the bus, and then I'm going to load that into that register there. Excellent. And we should then be able to unassert this from the bus, tell this one to assert to the bus, so that appears down here, and then we tell the register at the top to load that value. Okay, that's cool. Okay, that's working. Moving all these lines around is fiddly and tricky, particularly, I mean, even now we've only got 3 devices, and we have to be very careful that we only assert one of these to the bus at a time. But that's what we built this circuit for a couple of videos back. So Very soon I'm going to use this to start controlling the bus, but I think we've got one more 8-bit device to do first, which will be the constant register, which is what I'll be assembling quickly in the next video. Okay, that's it for now, but thank you very much for watching. Goodbye.